Good morning, students. Today we will be discussing about the process scheduling in operating system. Let's see what is meant by a process. Process is a program in execution. So why it should be scheduling? Because when a program to be executed, that must be present in the memory. So a different process will be there in the memory, and which process to execute. For any process to execute, we need the CPU time. So how the process can be scheduled to CPU so that each and every process will get the execution time. So process scheduling by definition, it is the overall OS mechanism that manages process states and transition during execution. So that includes the creation of a process, movement between the state, management of all the queue. These are the three things that comes under process scheduling. So as I said, process is is a program in execution. So the operating system will create a new process, and it will be moving around different states of a process like new, ready, running, wait, and terminated. When a process is created, it will be in new state. When a process is ready for execution by the CPU, it will be in the ready state. When the CPU is running the process, it will be in the running state. Sometimes the process has to wait for some input or output, then it will be in a waiting state. Once the process gets over, it will be in the terminated state. And at the same time, then all these states are actually maintained by using different queue. So what are the different queue available? Job queue, ready queue, waiting queue. These are some of the examples of the queue. So what is meant by scheduling queue? A scheduling process involve multiple queue. Job queue contain all the process in the system. The ready queue holds the process waiting for CPU allocation. That is, it is ready for execution. Now it has to get the turn from the CPU. And the waiting queue has process waiting for input-output operation. So these queue manage process states and transition critical for efficient CPU scheduling. And let's see about what is a job queue that contains all the process in the system. So there are different types of algorithms to maintain the job queue. So process stored in the job queue. Uh, so that will be stored in the job queue when it is submitted, usually maintained on the disk, that is hard disk. So from the job queue, process are admitted to memory by the long-term scheduler, or that we call it as a job scheduler. So that is the importance of a job queue. So any process when it is stored on the disk, when it comes to the system, when it is stored in the disk, it will be in the job queue. So from job queue, the jobs will be shifted to ready queue with the help of job scheduler, and then ready queue contain process that are in the main memory, and that is now ready for execution. Now it will be waiting for the CPU time. So that can be implemented by different algorithms, like it can be FIFO queue, priority queue, or a linked list. So the CPU scheduler or the short-term scheduler select the process from this queue. And the next is the waiting or the device queue contain the process that are waiting for input output devices. So any process that are actually was there in the ready queue, but now it got the CPU time by the job scheduler, sorry, short-term scheduler. And in between, if it needs an input output service, then that means the process has to wait for the input output request to be satisfied. Then it will be moved to waiting queue. So there are two examples, disk queue and the printer queue. If it is a if it is a demand for a disk operation, it will be stored to the disk queue. If it is a printer request, it will be stored to the printer queue. So this is a diagram of how it works. First it will be in job queue. From there it will be moved to the ready queue. And from the ready queue, it will be the process will be running. So that's running the process. So for input output, in case if the run in between running, if it is and there is an IO request, it will be moved to waiting queue or running process. The process exit means that will be moved to the terminated. So from the waiting queue, again it will be moved to the ready queue. So this is how it is. The states are changed from one process to the other process. Next, we'll see what is meant by CPU scheduling. So CPU scheduling refers to the process from ready queue, and that is the refers the movement of the process, or it is storing the process from the ready queue and it is assigning to the CPU. So that is the function of a CPU scheduling. That is from the ready queue that has to be moved to the CPU so that it can manage the CPU allocation among the process. And it's very important. That's a crucial role to maintain the system responsiveness and balance workload. That will help for balancing the waiting period and minimizing the response time. This is again showing the what is the importance of the CPU scheduling. That is fair for CPU time, optimizing system performance and CPU utilization in a multitasking environment. Thank you for listening. So this is the importance of the CPU scheduling, and this is how it works.